It's almost as if the solar system was carefully designed. Our solar system is filled with diverse celestial bodies, each with unique features. For example, Earth has life, Jupiter has its great red spot, and Saturn has its beautiful rings. The whole solar system is full of diverse celestial bodies. This star you see, shining brightly and giving off heat, is the central body of the solar system, the Sun. Orbiting around it are 8 major planets and other smaller celestial bodies. Among these planets, the one sometimes appearing brightest in our night sky is Venus. Often mistaken for a star, it's very likely Venus. This is a real photo of Venus sent back by a former Soviet Union Venus probe. You can see its surface looks like an extremely dry desert. Because Venus has an incredibly strong greenhouse effect, this causes its surface temperature to reach over 400 degrees Celsius. It's the hottest planet in the solar system. Almost no Earth life could survive there. Mercury is the smallest of the 8 planets and also the one closest to the Sun. The temperature difference between day and night on its surface is huge. During the day, it can reach as high as 427 degrees Celsius, while at night it can drop to as low as -172 degrees Celsius. Through images mapped by the Messenger Mercury probe, we can see that Mercury is covered in impact craters of all sizes, looking somewhat similar to the Moon. Next, the Sun is naturally the core of the solar system. Its size might be far beyond what you expect. Its volume is large enough to contain about 1.3 million Earths. Every second it fuses about 600 million tons of hydrogen into helium, ensuring it continuously shines and provides heat and sends some of that energy to Earth. In other words, the energy that powers your body to walk or drives your brain to think, ultimately all comes from the Sun. Besides Earth, Mars might also become a future home for humanity. Currently, rovers like Curiosity, Perseverance, and Zhurong have visited Mars. The reason its surface appears reddish-orange is because the soil contains a certain amount of iron oxide. Further out from Mars is the asteroid belt. This region is filled with about 500,000 asteroids. Most are made of rock or metal. It looks very dense, but actually this is only dense in astronomical terms, because our space probes often fly through here and have never had any collision incidents. After passing through the asteroid belt, we reach Jupiter. Among the 8 major planets, Jupiter is the largest in both mass and volume. Because Jupiter's gravity is so strong throughout history, it has shielded Earth from many impacts by incoming space objects. You could call it Earth's bodyguard. It has an iconic feature on its surface, the Great Red Spot. This is a gigantic storm spinning like a cyclone. It's large enough to swallow the entire Earth. Next up is Saturn. Like Jupiter, Saturn is a gas giant planet. It doesn't have a solid surface. But what's most impressive about Saturn, besides having Titan, a moon that might potentially harbor extraterrestrial life, is its unique rings. These are planetary rings made of billions of ice chunks and rock fragments. However, it's predicted they will completely disappear within about 100 million years. And finally, there are Uranus and Neptune. They are considered sister planets. They are both ice giants and they look quite similar. Uranus is unique in the solar system because it orbits the Sun tilted way over on its side. And Neptune is the farthest planet in the solar system, up to 4.5 billion kilometers from the Sun. Deep inside, it might even be raining diamonds. Beyond Neptune lies the Kuiper belt. Although it's similar to the asteroid belt, it's much, much larger. Some objects here are massive enough for their own gravity to pull them into a spherical shape, and these are called dwarf planets. For example, Pluto is one of them. Continuing outward from the Kuiper belt, it's just darkness. But this doesn't mean we've reached the edge of the solar system yet, because our solar system is actually thought to be surrounded by a theoretical region called the Oort cloud, which envelopes it. This consists of many remnants left over from the birth of the Sun. They surround the entire solar system, covering a diameter of about 2 light-years. Only when humanity completely passes through this Oort cloud can we perhaps be considered to have truly left the solar system. However, even as our solar system recedes to a mere point of light, remember that it contains our home, our history, and the potential for our future among the stars. Though the universe is vast, our capacity for exploration, discovery, and connection remains immense. Our journey has just begun.